Good morning, this is Mr. Shields back again with part 2 of our video on multiplying radicals. So the two types that we have to look at here are using the distributive property first and foremost. And I think go ahead and look at our first example here. So I have the square root of 6 times 3. So I'm actually going to write this out so you can kind of see what that looks like. All right, and you'll notice that the square root of 6, the only coefficient is an imaginary 1, and you'll notice the 3 doesn't have a radical sign. So if I were to multiply those, I would actually put the 3 to the front, and I would have 3 square root of 6. But you'll notice if I'm doing the square root of 6 times the square root of 8, I'm just multiplying the numbers within the radical sign here. So what is that going to look like? Well, 6 times 8 is just 48. Okay, and so then we have plus the square root of 48. Now, as you can probably guess, we can simplify something here. The 6 really can't go down any further here, so we're pretty good to go there. But if we bring back our perfect square card, you can probably imagine 48 can be broken down. Be careful, don't go for the first thing here when you're breaking it down. Some of you might look at that and say, oh, 4 is my biggest perfect square that can go into 48. Well, 4 will go into 48, but my biggest perfect square that I want is actually the number 16. And when I divide 48 by 16, I get 3. All right, so time for us to do a little simplification. I'll move a card down here. And so the square root of 16 is just 4. And then we'll have the square root of 3 right next to it. And now I'm going to bring down here my 3 square root of 6. Now, can I combine these terms? Well, no, because if you look under the radical sign, I have a 3 and I have a 6. So really, this is my final answer here. There's nothing further that I can do with this, so we can kind of call it a day on that example. So what about example 2? Let's get with the distribution here. So 4 times 2 is going to be 8. Now, if I do 4 times that negative square root of 3, be careful how that's going to look when you write it. So it's actually going to be a minus, because you see that minus 1 here. It's an imaginary 1. So I'm going to have a negative 4 square root of 3. Okay. Underneath, when I do my distribution, I'm going to have the square root of 3 times 2. And so watch how I write this. I'm actually going to write 2 square root of 3. Okay. And if you're a little bit unsure how I wrote it that way, go back and look at that first example here where we had just a radical sign and a coefficient that we were multiplying. Okay, we couldn't multiply these directly because this is under the radical sign and this wasn't under a radical sign. So we just put the coefficient in front. All right, and then last but not least, we have the square root of 3 times the square root of 3, or the negative square root of 3, I should say. And that one, we can just multiply the numbers under the radical sign. And so 3 times 3, that will be a 9. Okay, so now that we've multiplied or used our distribution property, we're actually going to go back and simplify certain items. So if I were to go ahead, probably the first thing you would notice is, hey, these two have a 3 under the radical sign. I can probably combine these terms. All right, so negative 4 plus 2. So I'll get a negative 2 square root of 3. All right, and then I'll bring down my 8. And I can also bring down my square root of 9. And as you can probably guess, perfect square. So if I take the square root of 9, I'm going to end up with that 3 here. And so I can write this here. And then actually there's one more step because I have 2 coefficients. I have my 8 and I have my negative 3. So my final answer, 8 minus 3, will be 5 minus 2 square root of 3. Okay, and so that's going to be the hardest example that we're going to have to do in terms of multiplying radicals here. All right, so I'm going to go ahead and do the odd number examples here on this page. So let's take a look at number 11 here. So as we go through number 11, I'm going to have to use my distributive property here that I mentioned in example 1. All right, and so if we do that, just zoom in a little bit here, get a little better focus for a video. So I'm going to have the square root of 15 times 2. All right, and so what you should notice, having a little focus issues on this video, I guess. What you should notice here is that I can't straight up multiply these, right? One of them's under the radical sign, the other one isn't. So I would have a 2 square root of 15, all right, for that first part of the distribution. Now the second part, I'm going to have the square root of 15 times the square root of 5. And so I can actually multiply all of those under the radical sign here. And so 15 times 5, that's just going to give me a square root of 75. Now it's time for our simplification phase here. Apologize for the focus issues. Now it's time for our simplification phase. So when we do that, 15 seems to be as broken down as far as you can go. The only perfect square we're going to that is 1. So we're good to go on that. So I can bring that on down. But the square root of 75, as you can probably guess, that one can be broken down a little bit further here. And so when we do that, the biggest perfect square is going to be 25. 75 divided by 25 is just 3. And so when we go ahead to finish this here, the square root of 25 is just 5 square root of 3. And then as I mentioned earlier, I'm just going to bring down my 2 square root of 15 because it can't go down any further. Then I'll add my plus sign. Can I combine those? No. Got a 15 under the radical sign and I got a 3 under the radical sign. So once again, we are finished with that particular problem here. So we just leave it like that. And I'll highlight my answers. Let's take a look at number 13. So we've got a lot going on in number 13 here when we use our distributive property. The good thing about the way this one is set up, if we just take a look at our first one here. So we're going to multiply our outside numbers, so -2 times 3. And when I do that, I'm going to get a -6. And then keep in mind, I'm going to multiply my inside numbers, so 3 times 10, which is going to give me a 30. All right. Now, on the flip side here, I'm going to be looking at these two radicals. So I'm going to have that -2 times that -3, which is going to give me a +6. And then on the inside, I'm going to have 3 times 6, which is going to give me the square root of 18. Okay. Now I didn't break that apart the way I did in the previous problem here in the interest of space and time here for our video. But as we go ahead to solve these, we need to see what we can simplify. Now, if I take a look at that square root of 30 to start us off, strangely enough, 1 is actually the biggest perfect square. So we're pretty good on that. So we don't need to simplify that any further. But 18, though, can be broken down, actually, because there is a perfect square that will go into it other than 1. And that biggest perfect square into 18 is just 9. All right, so when we do that, 18 divided by 9 is 2. We'll bring down our 6. And when we take the square root of 9, we're going to end up with a 3 times the 6 on the outside. And so when I do that, 6 times 3 is just 18. So we'll have 18 square root of 2. Now we'll bring down our -6 square root of 30 right here, and then we'll have our plus sign there. Now, can I combine these terms? No, not really. We have a 30 under the radical sign. We have a 2 under the radical sign. So we are pretty much finished with this problem here. We can't simplify it any further than that. So let's take a look at some of our FOIL examples here. So I'm going to look at number 15 here on the start. And so we'll go up top here with our CLAM method. And so if you take a notice of what we're going to do here, and I'm going to break this apart actually. So I'm going to have the square root of 5 times the square root of 5. So all that's under the radical sign. And so we'll end up with the square root of 25. Square root of 5 times the 4 here. And when we do that, remember, since this one has a radical sign, that one doesn't, we'll just have the 4 square root of 5. Okay? So I just broke that apart for you just so you kind of see what's going on for those of you struggling a little bit with that. Others of you, I know you guys can probably just dive right in and go ahead and do that. So if I go underneath here, once again, I would have a little multiple addition sign here. And so I would have 2 times the square root of 5. Okay. So there's really nothing much that I can do with that. So I can just bring that on down as the 2 square root of 5. And then last but not least, 2 times 4, which is just going to give me an 8. Now, some of you, all right, so let's go ahead and simplify. There are a couple places that you could start. Probably the quickest one is you see that I have a perfect square of 25, and the square root of that is just 5. Now, the other thing that you might notice right away is that, hey, I've got a 5 under the radical. I've got a 5 under the radical sign here. Maybe, just maybe, I can go ahead and add those. And yes, you can. So 4 plus 2 on the outside will give me a 6 square root of 5. And then, of course, we can bring down our plus 8. Last thing we can do to simplify, add those terms on the bookends here. So 5 plus 8 will give me 13 plus 6 square root of 5. That's my final answer here. We're going to be distributing using our CLAM method up top. So 6 times 5, that's going to give me a 30. And then I'm multiplying my inside here, square root of 3 times the square root of 3, and I'm going to get a 9. Okay, so I did that first little arrow here. The next arrow I'm going to do, I'm going to have 6. Now remember, that's on the outside, right? So I'll have 6 times that minus 4, and that'll give me a negative 24. But I can't multiply the square root of 3 times 4. So I can just bring it right down next to it, and I'll have the square root of 3 to go with it. Now we'll go underneath for our shell here. So I'm going to multiply here that negative 2 times that 5, which is going to give me a negative 10. But there's nothing that I can multiply the square root of 3 with here. So it's just going to stay the same as the square root of 3. And then finally, negative 2 times negative 4 here, that's going to give me a positive 8. Simplification time. The thing that hopefully stands out to you the most clearly are these two terms. They both share the 3 on the inside of the radical sign here. So negative 24 minus 10 is going to give me a negative 34 square root of 3. And we can bring down our other items here. And I can also do some simplification with that square root of 9. As you can see here, it is a perfect square. So we'll have 3 when we take the square root of that times 30, which is going to give us a 90. So I'll bring down my other terms here. We're almost finished. And the last thing we need to do is combine our like terms. We have an 8, we have a 90, put those together, we'll end up with a 98 minus 34 square root of 3. All right, so that's our final answer here.